Hey guys, welcome back. Let's take a look at ionic compounds. Ionic compounds are going to be different than covalent compounds, and we're going to take a look at some of those differences. Let's take an example of fluorine and chlorine bound together. The chemical formula for this would be FCl. And the ratio would be 1F bound to 1Cl. Our molecular formula would also be FCl. This is not true for ionic compounds. Sodium chloride would have a chemical formula of NaCl. We would see a ratio of 1 Na for every Cl. But there would not be a molecular formula because it's ionic. Instead, there would be a unit cell representing the way in which the sodiums and chlorines organize themselves. This unit cell has a very specific shape. This unit cell would be repeated upon itself several times, and then that unit would be repeated upon itself several times. This would form what is known as a crystal lattice. A crystal lattice is the repeating units of the unit cell over and over and over again until it makes the solid that we see with our eyes. The charges in the unit cell create strong bonds as they are stacked upon each other over and over again. The unit cells are tightly packed. This, combined with the strong forces, results in immobility or a lack of movement of the atoms or cells. This is why ionic compounds tend to be brittle. The energy between the unit cells that make the crystal lattice is called the lattice energy. This energy refers to the amount of energy released when 1 mole of the gaseous ionic compound becomes a solid. So in this scenario, our compound is so hot that it has become a gas, and then it cools down into solid state. The energy released in this state is the lattice energy. It is typically denoted as a negative number because of its enthalpy value, but in either case, the larger the number, the stronger the bonds. Therefore, lattice energy can help predict the strength of an ionic compound. So whenever the crystal lattice is melted, some of the bonds are broken. Therefore, there is some charge in the molecule, and that allows electric current to run through the charges of the positive and the negative. This is why ionic compounds can conduct electricity when they are in liquid states, but not when they are in solid states. This is also true when ionic compounds have been dissolved into water. The dissolving in water separates the ions into positives and negatives and allows for electricity to be passed through between the bonds. That's all. See you next time. Bye-bye.